Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be writing equations of parallel and perpendicular lines. This is part 2 of a two-part lesson. Before we get into some examples, let's identify the steps that are required to write these equations of parallel and perpendicular lines. In step 1, you want to identify the slope of your original line. In step 2, you're going to identify also the slope of the new line. If this new line is parallel, the slope will be the same. If the new line is perpendicular, the slope will be the opposite, reciprocal. Then you're going to use slope-intercept form, y equals mx plus b, to find the y-intercept of the new line. In step 4, you'll use the slope of the new line from step 2 and then the y-intercept from step 3 to write your new equation. Now, I like to check your answer with technology. I'm going to be using Desmos to do that, but you can use any graphing calculator. All right, in example 1, it says write an equation for the line that passes through the point negative 21, 4, and is parallel to the line represented by the equation y equals 1/3 x minus 2. So let me graph our original line here. We have 1/3 x minus 2. This is our original line here in red. And so m sub o, that means original slope of our original line is 1/3. Now, because they're wanting us to write an equation for a new line that is parallel to the original line, that means our parallel slope is also 1/3 because the parallel lines will always have the same slope. Now, I want my new point to go through the point negative 21, 4. So I know my new equation is going to look like this. Y equals 1/3 x plus something, or y equals 1/3 x minus something. That's what we're going to find out, what the y-intercept is. So to do that, this is step 3. We're going to use slope-intercept form, y equals mx plus b, to find the b, or the y-intercept. All right? So what I'm going to do is I'm going to use the new point that they gave us, that they want our new line to go through, and I'm going to label it x and y, and then I'll plug in these points to our formula. So for the y, we'll plug in a 4. For the m, we'll plug in a 1/3. For the x, we'll plug in a 21, and then plus b. B is what we're trying to find, the y-intercept. We do not know that yet. So let's simplify this. 4 equals 1/3 of negative 21 would be negative 7. And then add 7 to both sides to isolate the b. So 4 plus 7 gives us 11. So now we know the y-intercept of our new line is positive 11. So that means my equation will be y equals 1/3 x plus 11. Now, before I box that in, I'm going to check it. And this is how I'll check it. I'll come over here to the my Desmos calculator here. I'm going to enter this equation, 1/3 x plus 11. Okay, I'm going to have to zoom out a little bit. So that is definitely a line that's parallel to the original line. But what we have to figure out is, does my new line, which is in blue, does it contain the point negative 21, 4? So let's type, negative 21, 4. Then I'm going to have it label it. Now, negative 21, I'm probably going to have to zoom out to see. Yep. Okay, so notice here, negative 21, 4 is indeed on that new line. So now we know we've got the problem correct. We're just checking to make sure that new line contains the point we're looking for. All right. Example 2. Write an equation for the line that passes through the point 15, negative 4 and is perpendicular to the line represented by the equation y equals negative 5/2x minus 3. So in this problem, our original slope, m sub o, is negative 5/2. Now remember, perpendicular slope will not be the same. It's going to be the opposite, reciprocal. So the opposite of a negative is a positive, And the reciprocal of 5 over 2 is 2 over 5. So now I know my new equation will look like this. Y equals 2 over 5x plus something, or y equals 2 over 5x minus something. The other thing I know about my new line is it has to go through the point 15, comma, negative 4. Now, before I go on, let me plot the original line just so you can see it. We want negative 5 over 2x, not y, x minus 3. Okay, negative 5 over 2x minus 3. All right, so it's graphed in purple here. All right, now, to find our b, or our y-intercept, we're going to use this formula, y equals mx plus b. For the y, I'm going to plug in a negative 4. For the m, I will plug in 2 over 5. For the x, I'm going to plug in a 15 plus b. So negative 4 equals 2/5 times 15 would be 6 plus b. Subtract 6 from both sides, and I get negative 10 equals b. So now I know my equation of the perpendicular line will be y equals 2/5 x minus 10. Now let's check that. So 2 over 5x minus 10. And then we're going to check the point 15, comma, negative 4. Label. And there it is. It is on the new line, so we know we have our answer correct. All right, example 3. Example 3. Write an equation of the line that passes through the point 3, negative 1, and is parallel to the equation x minus 3y equals 9. Now, this time, it's a little bit harder to identify our original slope because our line is written in standard form. So if your line is written in standard form, we're going to need to rewrite that into slope-intercept form. So let's subtract x from both sides. We want to get the y by itself. So this would zero out. Negative 3y would equal 9 minus x, and then divide everything by negative 3. So y would equal 9 divided by negative 3 is negative 3. Now be real careful here because this is an understood one. And we have a negative 1 divided by a negative 3, which would be positive 1/3 x. So that is our original line, negative 3 plus 1 over 3 x. All right. So my original slope, I can now tell, is 1/3. All right. Now, I want this line, my new line, to be parallel to the original line. So that means my new slope will also be 1/3. So my equation is going to look something like this. Y equals 1/3 x plus something, or y equals 1/3 x minus something. So the point we want it to pass through is 3, negative 1. So let's use our slope-intercept form, y equals mx plus b. We'll put a negative 1 for the y, a 1/3 for the m, a 3 for the x plus b. So negative 1 equals 1/3 of 3 is 1 plus b. Subtract 1 from both sides to get negative 2. So now I know my equation is y equals 1/3 x minus 2. So let's come over here and check it. 1/3 x minus 2. Ooh, they're very close together. That's okay. We should still be able to see the point though. 3, comma, negative 1, and label. And sure enough, it did fall on that new line. So we know we have the correct answer. All right, example 4. Write an equation of the line that passes through the point negative 5, comma 1, and is perpendicular to x plus 4y equals negative 28. So to get our original slope, we're going to have to rewrite x plus 4y equals negative 28 into slope-intercept form. So we'll subtract x. So that will give us 4y equals negative 28 minus x, and then divide everything by 4. So y equals negative 7 minus, remember this is an understood 1. So our original slope is going to be negative 1/4. Negative 1/4. Now, if I want the opposite reciprocal of that, the opposite of a negative is a positive, and the reciprocal of 1/4 is 4/1, which will just reduce that to positive 4. So our perpendicular slope will be positive 4. So I know my new equation is going to be y equals 4x plus something or 4x minus something. All right. Now, the point we want our line to go through is negative 5, 1. So use your slope-intercept form, y equals mx plus b. We'll put a 1 for the y, a 4 for the m, negative 5 for the x, and then plus b. So 1 equals negative 20 plus b. Then add 20 to both sides. So 21 is equal to b. So our equation is 4x plus 21. Now let's check this answer. Our original line was negative 7 minus 1/4x. Our new line that's going to be perpendicular to that is 4x plus 21. And then we want to make sure that line goes through the point negative 5, comma 1 label. Yes, it does. So we know we can box that in. All right, example 5. Write an equation that passes through point P and is perpendicular to the line shown. So in this problem, they didn't give us an equation. So to get your original slope, you're going to have to use rise over run. So let me pick 2 friendly points here. Those 2 should work. So my slope is up 1 and left 3. So negative 1/3 would be my original slope. Okay. They want the new line to be perpendicular to the original line. So the opposite of a negative is a positive, and the reciprocal of 1/3 is 3/1. So my perpendicular slope will just be positive 3. So I know my equation is going to be y equals 3x plus something or y equals 3x minus something. Now, the point they want it to pass through is point P. So let's label point P. So negative 1, 2, 3, 4, 5. Negative 5, negative 1 is the point they want us to use. So y equals mx plus b. I'll put a negative 1 for the y, a 3 for the m, negative 5 for the x, plus b. So negative 1 equals negative 15 plus b. Now add the 15 to both sides, and I get 14 equals b. So 3x plus 14 is our new line. So what I'm going to do is we're going to check this on the calculator. Let me get rid of our old equations here. Our original line was negative 1/3 x plus 2. That was our original line. Our new line is 3x plus 14. And I want to make sure it passes through the point negative 5, comma, negative 1 label. And sure enough, it does. So our new equation is y equals 3x plus 14. And that concludes today's lessons, writing equations of parallel and perpendicular lines, part 2.